Ancient Greek mathematicians noticed that when you divide a string into two equal parts, the frequency doubles to the octave, as in do, re, mi, fa, sol, la, ti, do. If we divide it into three equal parts, that becomes the fifth degree of the scale, changing the note to so, do, re, mi, fa, so. If we rearrange all 12 of these notes within our octave in order of how they appear by dividing string lengths by 3, which, if we remember, is the simplest way to get a new note, what we arrive at is a cyclical pattern of notes, here shown as the circle of fifths. Today we are going to build our own stringed instrument in our mind. Let's call it a guitar. And since we cannot write on a string, we can write on a two-dimensional piece of paper. Here I'm writing 2 octaves from C all the way up to B just before the third C. Each of these strips of paper will represent a string. But how shall we tune our new instrument? The string relationships, or intervals that we're using for our instrument, are what we would refer to as the tuning of the instrument. The tuning used for our guitar will be inspired by the natural relationships within one string as it is divided into half and 3 equal parts and fifths and so on. We begin by tuning the first low string on our instrument to E, and the next string to A, and the next string to D, and the 4th string to G. But something starts to happen. If we were to keep going, we would wind up with a 12-stringed instrument if we continue to go around our entire circle of fifths. And we're not building a harp, we're building a guitar. So if we offset this, and instead of going from G to C, but we go to B, the next step would arrive at a final high E string, creating a 6-stringed instrument with very flexible chord voicings, as you will start to see when you continue your journey learning how to play the guitar.